Okay, so we saw last hour that if we have that equation set up in this form, y equals a number multiplying x. So let's go with like negative 1/2 times x plus or minus another number. Let's go minus 3. Then we can graph it straight from the information in that equation. The minus 3 is our starting point. That means that from the origin, we're going to go down 3, and that's where we're going to start our line, right there. The number multiplying the x is the slope, and that tells us where to go. Once we have a starting point, that tells us where to go. So it's a negative 1/2, so the negative always goes with the rise. The run will always go from left to right, but the rise can either go up if it's positive or down if it's negative. So negative 1 means from this point, we go down 1, and then the 2 means we run 2. So there's our second point. If I wanted to, I could do it again. Down 1 over 2. There's my line. So if I have y equals 2x plus 1, where am I going to start this graph? From the origin, I'm going to go up 1, because this is a positive 1 here. Now from there, it's the number multiplying the x that tells me the slope. However, it's just a 2 there. I have to turn it into a fraction by doing what? 2 over 1. Now I have a fraction. The numerator is the rise. So from this point, I go up 2. And then I run 1, so over 1. There's a second point on the graph. I could draw it through there if I want to. Or I could have done another point up 2 over 1 if I want to be sure. So how about y equals negative 3x plus 2? Where do I start? Positive 2. From the origin, I go up 2. It's because the plus 2 here. Now my slope is a negative 3. I'm going to make that a negative 3 over 1. So now from this starting point, where do I go? It's a negative 3, so I go down 3 over 1. Run 1. There's my line. So how about this one? In your notes quick, kind of sketch that out, and we'll go over it in just a second. So where do I start on that one? Negative 3, good. Down here. Now my slope is 3/4, so from here I go I'm going to rise 3. 1, 2, 3. And I'm going to run 4. 1, 2, 3, 4. So here's my second point. Now I'm one that I talked a little bit when we did percents about benchmarks. I'm going to talk a little bit more here. One that I always use is a slope of 1. A slope of 1 will go across the graph at a 45-degree angle like that. A perfect slope. If the slope is less than 1, 3/4 is obviously less than 1, my slope should be less than that. It should be less steep than that. If it's more than 1, like 2 or 3, obviously it should be more steep than that. So keep that in mind as you're graphing. In your notes, I want you to try to graph a couple. Try those 3 in your notes quick. We'll go over them in just a second. Let's look at the ones you have. This top one up here. As always, we start at the center, at the origin, and from there, where do we go? +2, as you go up 2. So our line's going to start at the +2, 2 on the y-axis. What do we do from there? Up 2, yep, that's exactly right, up 2 over 3. So there's our second point. Like that. Second one. Now I put this one in a little bit different order. Where does this one start? +3. The number that's being added or subtracted here is really the 3. It's positive, so it's added. It's a +3. So that's where this line is going to start on the graph, +3. The number that is multiplying the x is the -2. It's -2, even though it's -2x, it's really a -2 times x. So that means it's a -2 over 1. So from that point, we're going down 2 over 1. There's my second point. Like that. The third one, where do we start? Down 4, -4. And from there, the slope is a -1/3. So we're going to rise a -1. We're going to go down 1 and run 3. Any questions on graphing so far? What looks different about this one? Yeah, y is not by itself. It's times 2 here. So we have to get y by itself to graph this. It has to be in that form, y equals. So to get y by itself, if it's being multiplied by 2, we're going to have to divide by 2. Now when we multiply or divide in an equation, we have to multiply each portion of the equation, or divide each portion of the equation. So here, 2y divided by 2, the 2's cancel out and we have y. Well, over on the right side, we have 2 portions. We have the 3x and we have the 4. Each of them has to get divided. 3x divided by 2, well, 3 divided by 2 is 1.5 or 1.5x. But I'm going to show you a trick. Remember, division and fractions are kind of interchangeable. So 3 divided by 2 can just be written as 3 over 2 with the x. So 3x divided by 2 is just 3 over 2x. 4 divided by 2? Positive 2. So that means this one's going to start at 2. And from there, we're going to rise 3, run 2. Right there. Looking at this one, what's different? The 3. It's y plus 3. So we have to get rid of it. It's added, so we're going to subtract it. Now, when we add or subtract to an equation, we only have to do it to one piece on each side. So we subtract 3 here to make that y. On the other side, where can we subtract 3 from? The 2. Can't subtract it from the x because it would have different names. So we've got the 2x. 2 minus 3 makes negative 1. So on my graph, where do I start? Negative 1 right there. And from there I go, there's a 2 over 1, I go up 2 over 1. How about here? Obviously, oops, I screwed up. That shouldn't be an x, that should be a y. Make a lot more sense if there was another variable in there, doesn't it? There we go, sorry. 3y minus 1 equals negative 4x plus 5. Well, the y is being multiplied by 3 and 1 is subtracted from it. So we have to get rid of both of those. Now, we can think about this just like we're solving any other equation. If we cover up that right side and only look at the left side over here, if we were solving that for y, which is basically what we're doing, we're trying to get y by itself, what would we do? Well, we would add 1 to get rid of the minus 1 first. That leaves us with 3y. Now we have to add 1 on the other side. Anytime we have an equation, whatever we do to one side, we do have to do to the other. So I add 1 there, I have to add 1 over here. Now remember, when I add or subtract, I only add or subtract to one piece on each side. So the 1 is going to get added to the 5. So I have my negative 4x. 5 plus 1 is 6. Now, I have the 3 to get rid of. I'm going to divide by 3 because it was multiplying the y. When I multiply or divide, I have to do it to every piece on each side. So negative 4x divided by 3, over here it's just y. Negative 4x divided by 3, I'm just writing as negative 4 over 3 times x. 6 divided by 3 is just 2. So I'm going to start at 2. That's the number that's added or subtracted. And from there, I have a negative 4/3 slope, so that means I go down 4 over 3. Any questions? Okay. This one is different still. X and Y are on both on the same side of this graph. So I still have to get Y by itself. I really don't care about X at this point. I am just trying to get Y all by itself. Because to graph it, I need Y equals. So what's happened to Y here? Y has been multiplied by a -2, and then 5x has been added to it. So to take this apart, to solve it for Y, I am going to start by subtracting 5x. So -2y here is all that's left. 6 minus 5x is just 6 minus 5x. There's nothing I can take it away from on the right side, so I just put them together like that. I have to get rid of the -2. It is -2 times y, so I'm going to divide by -2. Gives me just y. Dividing this side by -2. 6 divided by -2 is -3. -5x divided by -2. -5 divided by -2 is a positive 5/2 x. To graph that, I'm going to start at -3, and from there I'm going to go up 5/2. Now, an alternative way of thinking of this slope, by the way, 5/2, is that is how far you go up or down for every unit you go over. So you could think of it as going over 1, up 5.5, over 1, or 5.5, up 5/2, up 2.5. Sorry, over 1, up 2.5, over 1, up 2.5, over 1, up 2.5. 5/2 of a shot. Gotta make the tongue work right today, apparently. I sounded like Elmer Fudd in my first class today. I was stuttering everywhere. So, let's have you guys try a few. You try that one. And that one. So this first one, do you need a little bit more time yet? We'll give you another minute or so. Okay, so for the first one, we have to get y by itself here. So we have to get rid of the 2x and the 3. So we're going to subtract 2x. So that's gone. We have 3y equals 3 minus 2x. Then we'll divide by the 3. Set it my way a little bit. So 3 cancels out. Y equals 3 divided by 3 is 1. Negative 2x divided by 3 is negative 2/3 x. So where do we start? Positive 1. From there we go down to over 3. Any questions on that one? Over here, I've got the y on the other side. I'm going to have to add 1 to make this 3x plus 6 equals 2y. And then divide by 2. So that's just y. 3x divided by 2 is 3 over 2x. 6 divided by 2 is a positive 3. So to graph that, I will start out at positive 3. And I will go up 3 over 2. Just a show of hands, how many had both of those right? Good deal. Anybody have any questions on any of them? Okay. Now, sometimes we don't have the equation of the graph. I mean, there are 2 pieces of information we had here. For each of these, we had the slope, and we had that y-intercept. But we don't necessarily have to have that y-intercept. The y-intercept really just served as a starting point for us. We can use any point as a starting point. If I tell you that a line goes through the point 2,5 with slope of 1/2, I can graph that, the point 2,5. Now, here's where you have to be careful. Slope goes vertical, then horizontal. It goes up and then over. When I'm plotting a point, the 2,5 here, remember when you're plotting coordinates, the first coordinate is horizontal. It's side to side, so it's going over 2. The second coordinate is our vertical, up and down, so we're going up 5. So there is the point 2,5. So be very careful. Our coordinates work backwards compared to our slopes. So that is the point 2,5. Now from that point we apply our slope. And the slope is rise over run. So we go up 1 over 2. There's our line. So all the y-intercept served as is a starting point for us. If we have another starting point along with the slope, we can still graph those lines. Or the obvious one is, if we're told it goes through 3,1 and 6,3. Well, again, if we know it goes through both of those points, all we have to do is do 3,1 and 6,3 and put the line through them. Any questions? Well, what do these all mean? Why are they important to you? Well, the slope is a rate of change. it is telling us how fast something is changing. For example, let's say you're looking at a snowman. And every day now it's warm enough that the snowman's starting to melt. You want to look at how tall it is. And let's say that on day 1, it was 5 feet tall. On day 4, it was down to 4 feet tall. And it continues at a linear rate of melting. Now what I can do here is I can actually do this, since I have this graph, I can actually draw in the slope triangle here, my rise and run. I rose, well, I went down 1. That's a -1, isn't it? I ran 3. So the slope of this is a -1/3. There's actually a little bit more to it than that. It's -1 foot per 3 days. Now, if you just put on a test, if you just put -1/3, I'm okay with that. But there actually are units in this. So it's -1 foot per 3 days, or you could look at it as -1/3 of a foot per day, if you divide it out. Now, looking at this, what if I just gave you the points that day 1, 5 feet tall, day 4, 4 feet tall? Could I have found the slope from just those points? Well, yeah, the rise is the difference in which coordinates, x or y? The y coordinates. Y goes up and down. The rise is the difference in the y coordinates. The run here is then the difference. Obviously, the only one that's left is the x coordinates. So if I have 2 points, like 1, 5 and 4, 4, I can find the slope of that line by looking at the difference in the y coordinates. The way we write that is the second y coordinate minus the first y coordinate, y2 minus y1, divided by the difference in the x coordinates, so x2 minus x1. So what does that mean? y2 is the second y coordinate. So I go to the second point, the y coordinate is 4, minus y1 is the first point's y coordinate. So point 1, the y coordinate is 5, over x2 minus x1. x2 is the second point, its x coordinate. It's 4, minus x1 is the first point, its x coordinate is 1. 4 minus 5 is -1. 4 minus 1 is 3, so it's a -1/3 slope. In this last unit, we talked about flow rates. So let's say that you hang a bag and at 3 hours, there are 800 milliliters of fluid left in the bag. There's 800 milliliters of fluid left in the bag. At 5 hours, it is down to 300 milliliters of fluid in the bag. So now what we're looking at is the flow rate is the rate of change of volume in the bag. So the first point is at 3,800. The second point is at 5,300. So my slope, y2 minus y1 over x2 minus x1. What is the y-coordinate of the second point? Second point is this one, 300. Minus, what's the y-coordinate of the first point? 800. Now you'll notice when I subtract that, I am going to get a negative 500. That's because the volume of the bag has been reduced by 500 milliliters. On bottom, x2, what is the x-coordinate of my second point? 5 minus x1. What's the x-coordinate of my first point? 3. 5 minus 3 is 2. So that's negative 500 over 2, which can be reduced to a negative 250. Now this was milliliters over hours. So that's changing by 250 milliliters per hour. The bag is being depleted at 250 milliliters per hour. Or if you want to look at the other way around, it would be positive in that other way, is the amount of medication going in the patient is 250 milliliters per hour. So this could actually be used to create a graph relatively easily. Let's say that at 3 p.m., you hang 1,200 milliliters to flow at 300 milliliters per hour. If I want to graph this, now this could be time 0. I'm going to label it as 3 p.m. I have to have my volume on here, so I'm going to call this 500, 1,000, 1,500. So at 3 p.m., there's 1,200 units there. That's my y-intercept. It's being depleted at 300 milliliters per hour. So I go down 300 milliliters for every hour. So at 4 p.m. it's at 900, 5 p.m. it's at 600, 6 p.m. it's at 300, 7 p.m. it would be at 0. And there's my line. So that slope does have meaning. Now I could also write the equation for this really quickly. Y equals 1,200 minus 300x or 300t, whatever I wanted to call it. I could have also said y equals negative 300x plus 1,200. It just makes more sense to me to do it like this, because it's starting at 1,200 and we're depleting 300 per every hour. So let's have you guys try one. At 2 p.m., the IV bag contains 1,300 milliliters. At 6 p.m., it contains 500 milliliters. Find the flow rate. quickest way for me to do this is to write the coordinates. 2 p.m., 1,300 milliliters. 6 p.m., 500 milliliters. So Y2 is 500 minus Y1 is 1,300. X2 is 600 minus Y2 is 200. 500 minus 1,300 is a negative 800. 6 minus 2 is 4. We divide that out, that is a negative 200. That is milliliters per hour. So the bag's being depleted at 200 milliliters per hour, or it's a 200 milliliter per hour flow rate. We've covered everything, and I'm losing my voice, so rather than do a couple more examples, I'm going to give you guys your homework. So on page 205, there's problems 1 through 3. You should probably look at all 3 of those. Those just go over some of your basic graphs. Page 213 through 217. So I'll look at 1 through 15, the odds. Page 221 through 222. Also 1 through 15, the odds. And page 226. Also 1 through 15, the odds. Next week is our final lecture of Unit 2, which means, unfortunately, you get to go away for the week for Thanksgiving and come back the following week for Unit 2? Unit 4. The second week of Unit 4 next week, the final week of Unit 4. So you do get to go away for the week for Thanksgiving and come back to Unit 4 test that Friday after Thanksgiving. So make sure you're looking ahead at that and staying on top of it. Okay, you guys have a great week.